So we have to find Fourier transform of this function. So definition of Fourier transform is f of lambda is equal to integral from minus infinity to plus infinity f of x e raised to minus I lambda x dx. Okay, you can change the variable from x to u, that means you will have f of u e raised to minus I lambda u du, but it is your choice. So keep x as it is. So minus infinity to infinity f of x e raised to minus I lambda x dx. This is the formula of Fourier transform and it is denoted by f of lambda. Okay, so f of lambda is equal to, now the range of integration is minus infinity to infinity, but the function is given in two parts. Okay, first part is you have 0 to pi as your range of that function, and second is otherwise. So how we can divide minus infinity to infinity? We can divide minus infinity to infinity as minus infinity to 0, 0 to pi, and then pi to infinity. So this range of integration is divided in three parts. For this part function is 0, for this part function is cos x, and for this part function is again 0. So this integration can be splitted as minus infinity to 0 f of x e raised to minus I lambda x dx plus 0 to pi f of x e raised to minus I lambda x dx plus pi to infinity f of x e raised to minus I lambda x dx. So f of lambda is equal to, what is f of lambda? It is Fourier transform. f of x is 0 for this range, minus infinity to 0 में फंक्शन क्या है आपका 0 है, इसका मतलब इंटीग्रैंड 0 हो जाएगा. ओके, dx प्लस 0 टू पाई में फंक्शन क्या है आपका, 0 टू पाई में फंक्शन है cos x, सो cos x इंटू ई रेज टू माइनस आई लैम्बडा एक्स डी एक्स प्लस पाई टू इन्फिनिटी में क्या फंक्शन है आपका 0 अगेन, सो पाई टू इन्फिनिटी 0 टाइम्स ई रेज टू माइनस आई लैम्बडा एक्स डी एक्स. तो एफ ऑफ लैम्बडा क्या हुआ फिर आपका, इट इज़ सिंपल 0 टू पाई, these two integrations are 0. Okay, integrands are 0, so integrations are 0. So 0 to pi cos x e raised to minus I lambda x dx. Okay, so in this f of lambda you have, it is of the formula e raised to ax cos of bx dx. Okay, now we have to find what are a and b, and what is this integration? It is equal to e raised to ax divided by a square plus b square into another bracket. Okay, so a cos bx plus b sin bx. Okay, this is the formula we have to use. Compare this integration with this integration, you will get values of a and b. A is what? A is multiple of x in the index, so it is equal to minus I lambda. What is a b? B is equal to multiple of x in the angle of cos. Okay, so it is 1. So simply f of lambda is equal to e raised to minus I lambda x divided by a square plus b square, that is minus I lambda square plus 1 square into bracket a times cos bx, that is minus I lambda times cos of b is 1, cos of x plus 1 times sin of 1 times x, that is sin x. Okay, limits of integration are 0 to pi. So f of lambda is equal to e raised to minus I lambda x divided by minus I square is I square, simply it is minus 1 into this lambda square, so it is clearly minus lambda square plus 1 into another bracket minus I lambda cos of x plus sin x, range of integration 0 to pi. So it is equal to f of lambda is equal to e raised to minus I lambda x divided by 1 minus lambda square into bracket minus I lambda cos x plus sin x 0 to pi. Now upper limit is pi, so put pi first. So after putting x is equal to pi, you will get e raised to minus I lambda pi divided by 1 minus lambda square into bracket. This is cos of pi, sin pi is 0, okay, so only one term will be there in the bracket, so minus I lambda cos pi is minus 1, okay, minus, now substitute the lower limit will be e raised to minus 0 is e raised to 0 and it is 1, so 1 by 1 minus lambda square into bracket cos of 0 is 1, sin 0 is again 0, so cos 0 is 1, so it is minus I lambda, close the bracket, so it is equal to minus I lambda into minus 1, it is plus I lambda, so I lambda e raised to minus I lambda pi divided by 1 minus lambda square minus, and this minus, so again it is plus, so plus I lambda divided by 1 minus lambda square, so you can rewrite it as I lambda into bracket e raised to minus I lambda pi plus 1 divided by 1 minus lambda square. This is the Fourier transform of given function f of lambda. Okay. So if you have questions of the type find the Fourier transform, then you can consider directly the formula without checking the nature of the function. Okay, that will be the easy way to find out Fourier transform.